Question 1. The review process indicates that a driver transporting materials for a chemical manufacturing plant encountered an unlabeled drum containing a viscous liquid. The shipper stated it was a byproduct from a recent process, but provided no further details or documentation regarding its classification. The driver is unsure if this substance falls under the definition of hazardous waste according to U.S. EPA regulations, which is critical for their CDL hazmat endorsement. Which of the following actions best reflects the driver's professional responsibility and adherence to regulatory requirements? Option A. Assume the liquid is not hazardous because it is not explicitly labeled as such and the shipper described it as a byproduct. Option B. Refuse to transport the drum immediately without any further inquiry, citing the lack of proper labeling and documentation. Option C. Proceed with transporting the drum, relying on the shipper's informal description and assuming it is a non-hazardous industrial waste. Option D. Consult the U.S. EPA definition of hazardous waste and relevant sections of their CDL hazmat training materials to determine if the liquid meets the criteria for hazardous waste, and if still uncertain, seek clarification from the shipper and potentially regulatory authorities before proceeding. The correct answer is D. Consult the U.S. EPA definition of hazardous waste and relevant sections of their CDL hazmat training materials to determine if the liquid meets the criteria for hazardous waste, and if still uncertain, seek clarification from the shipper and potentially regulatory authorities before proceeding. Explanation. This scenario presents a professional challenge because it requires a commercial driver's license, CDL, hazardous materials, hazmat, endorsement holder to make a critical judgment call regarding the classification of a substance. The driver is not a chemist or environmental scientist, but their understanding of hazmat regulations is paramount for public safety and environmental protection. The challenge lies in applying the regulatory definition of hazardous waste to a substance that is not explicitly listed on a manifest or in a standard shipping document, forcing the driver to interpret and apply the rules in a real-world, potentially ambiguous situation. The correct approach represents best professional practice because it prioritizes safety and regulatory compliance above all else. By consulting the relevant U.S. EPA, Environmental Protection Agency, regulations, and the CDL hazmat endorsement training materials, the driver is actively seeking to understand if the substance meets the criteria for hazardous waste. This proactive and informed decision-making process, which involves seeking clarification and adhering to established definitions, is the cornerstone of responsible hazmat transportation. It ensures that the material is handled, transported, and disposed of according to the strict protocols designed to prevent environmental contamination and public harm. An incorrect approach would be to assume the substance is not hazardous simply because it is not explicitly labeled as such or because it appears to be a common industrial byproduct. This assumption bypasses the driver's responsibility to verify the nature of the cargo. Ethically, it demonstrates negligence and a disregard for the potential risks associated with transporting unknown or misclassified hazardous materials. Regulatory failure occurs because it violates the fundamental principle of hazmat transportation, to know and comply with the hazards of the materials being transported. Another incorrect approach would be to proceed with transport based on a casual conversation with the shipper without independent verification. This relies on hearsay rather than regulatory definitions and established procedures. It is a failure to exercise due diligence and places undue trust in potentially incomplete or inaccurate information. This approach is ethically questionable as it prioritizes expediency over safety and regulatory adherence. A third incorrect approach would be to refuse to transport the material without any attempt to understand its potential hazardous nature. While caution is important, a complete refusal without investigation can impede legitimate commerce and may not be justified if the material, upon proper evaluation, is determined not to be hazardous. However, in the context of ambiguity, erring on the side of caution and seeking clarification is always preferable to proceeding without understanding. The professional reasoning process should involve 1. Identifying the ambiguity, 2. Recalling the regulatory definition of hazardous waste, 3. Consulting official resources, EPA regulations, training materials, 4. Seeking clarification from the shipper and, if necessary, regulatory authorities. 5. Making a decision based on the regulatory definition and available information, prioritizing safety and compliance. Question 2. The analysis reveals that a commercial driver is tasked with unloading a shipment of Class 3 flammable liquids at a customer's facility. Which of the following actions, if taken by the driver as the primary safety measure before initiating the unloading process, best demonstrates adherence to safe unloading practices under U.S. hazardous materials regulations? Option A. Proceeding with the unloading after a brief visual confirmation that no obvious hazards are present, relying on the customer's personnel to manage any specific site safety requirements. Option B. Immediately connecting the transfer hoses to the vehicle's cargo tank and the receiving vessel, assuming the facility has prepared the area for safe unloading. Option C. Contacting the receiving facility's manager to confirm they have completed their safety checks and are ready for the delivery, without personally verifying site conditions or equipment. Option D. Thoroughly inspecting the unloading area for any potential ignition sources, confirming proper grounding and bonding connections are established, and verifying the receiving vessel's suitability for the cargo. Correct answer is B. Immediately connecting the transfer hoses to the vehicle's cargo tank and the receiving vessel, assuming the facility has prepared the area for safe unloading. Explanation. The analysis reveals a scenario where a commercial driver transporting hazardous materials is preparing to unload a shipment of flammable liquids. This situation is professionally challenging because the unloading process itself presents significant risks of fire, explosion, or release of hazardous substances if not conducted with extreme diligence and adherence to strict safety protocols. The driver's primary responsibility is to ensure the safety of themselves, the public, and the environment, which requires a thorough understanding of the specific hazards of the cargo and the correct procedures for its safe transfer. Careful judgment is required to identify potential hazards at the unloading site and to implement appropriate mitigation strategies. The correct approach emphasizes a systematic and proactive safety check before initiating any unloading activities. This involves verifying that the unloading area is clear of ignition sources, ensuring proper grounding and bonding procedures are in place to prevent static electricity discharge, confirming that all necessary personal protective equipment, PPE, is worn, and that the receiving equipment is compatible and in good working order. This approach represents best professional practice because it directly aligns with the core principles of hazardous materials transportation safety, as mandated by regulations such as the U.S. Department of Transportation's Hazardous Materials Regulations, HMR, found in 49 CFR Parts 100-185. Specifically, these regulations require carriers and drivers to take all necessary precautions to prevent incidents during the loading, unloading, and handling of hazardous materials. The emphasis on pre-unloading checks is a fundamental safety measure designed to mitigate the inherent risks associated with flammable liquids, thereby preventing potential fires, explosions, and environmental contamination. An incorrect approach that bypasses pre-unloading safety checks, such as proceeding directly to connect hoses without verifying the absence of ignition sources or proper grounding, represents a significant regulatory and ethical failure. This directly violates the HMR's mandate for safe handling and unloading procedures. Ethically, it demonstrates a disregard for the safety of others and the environment, prioritizing speed or convenience over established safety protocols. Another incorrect approach, such as assuming the receiving facility has implemented all necessary safety measures without independent verification, is also professionally unacceptable. While facilities have their own responsibilities, the driver remains accountable for ensuring the safe transfer of the hazardous material under their care. This failure to verify can lead to catastrophic accidents if the facility's safety systems are inadequate or have malfunctioned. Relying solely on the receiving party's assurances without performing one's own due diligence is a breach of the driver's duty of care. The professional reasoning process for similar situations should involve a clear, step-by-step safety checklist derived from regulatory requirements and best practices. This checklist should be consulted and followed meticulously before, during, and after the unloading operation. Professionals should always prioritize safety over expediency, be prepared to halt operations if any unsafe condition is identified, and maintain clear communication with all relevant parties. Understanding the specific hazards of the material being transported is paramount, and this knowledge should inform every decision made during the unloading process. Question 3. The efficiency study reveals that a large motor carrier operating a fleet of commercial motor vehicles, CMV, transporting hazardous materials is experiencing delays in its driver training record management. Which of the following strategies best addresses this challenge, while ensuring compliance with federal hazardous materials transportation regulations? Option A. Update training records only when a driver is involved in a specific incident or during their annual performance review. Option B. Continue relying on paper-based records and manual verification processes, with a focus on improving the filing system to reduce search times. Option C. Delegate the primary responsibility for maintaining and submitting all hazardous materials training documentation to individual drivers, with minimal carrier oversight. Option D. Implement a centralized digital system for tracking and verifying all hazardous materials training records, ensuring immediate updates and easy accessibility for regulatory review. Correct answer is D. Implement a centralized digital system for tracking and verifying all hazardous materials training records, ensuring immediate updates and easy accessibility for regulatory review. Explanation. The efficiency study reveals that a large motor carrier operating a fleet of commercial motor vehicles, CMV, transporting hazardous materials is experiencing delays in its driver training record management. This scenario is professionally challenging because maintaining accurate and up-to-date training records for hazardous materials drivers is not merely an administrative task. It is a critical component of regulatory compliance and public safety. The Federal Motor Carrier Safety Administration, FMCSA regulations, specifically under 49 CFR Part 172, Subpart H, mandate comprehensive training for all individuals involved in the transportation of hazardous materials. Failure to comply can result in significant penalties, including fines and revocation of operating authority. But more importantly, it compromises the safety of the public and the environment by potentially allowing untrained or inadequately trained drivers to handle dangerous substances. Careful judgment is required to balance operational efficiency with the stringent safety and regulatory demands of hazardous materials transportation. The correct approach, which involves implementing a robust, centralized digital system for tracking and verifying all hazardous materials training records, represents best professional practice. This system ensures that records are current, easily accessible for inspection by regulatory authorities, and provide an auditable trail of compliance. It directly addresses the FMCSA requirements for ensuring that drivers possess the necessary knowledge and skills to safely handle, transport, and respond to incidents involving hazardous materials. This proactive and systematic approach minimizes the risk of noncompliance, enhances safety protocols, and demonstrates a commitment to responsible hazardous materials management, aligning with the ethical imperative to protect public safety. An incorrect approach that involves relying solely on paper-based records and manual verification is professionally unacceptable. This method is prone to human error, loss of documents, and significant delays in updating information. It creates a high risk of noncompliance, as records may be incomplete or outdated, leading to potential violations during roadside inspections or audits. Ethically, it fails to uphold the duty of care required when transporting hazardous materials. Another incorrect approach, which is to only update training records when a driver is flagged for a specific incident or during annual reviews, is also professionally unacceptable. This reactive strategy is insufficient because FMCSA regulations require ongoing and comprehensive training, not just remedial action. It creates gaps in compliance and fails to ensure that drivers are consistently equipped with the latest safety information and procedures. This approach neglects the proactive safety culture essential for hazardous materials transportation. A third incorrect approach, which is to delegate the responsibility for maintaining training records entirely to individual drivers without a centralized oversight mechanism, is professionally unacceptable. While drivers are responsible for completing training, the motor carrier has the ultimate legal and ethical responsibility to ensure that all training is documented, verified, and compliant with federal regulations. This delegation creates a fragmented and unreliable system, increasing the likelihood of missing or inaccurate records and failing to meet the carrier's overarching safety obligations. The professional reasoning process for similar situations should involve a thorough understanding of the applicable FMCSA regulations, specifically 49 CFR Part 172, Subpart H. Professionals must prioritize a systematic and verifiable approach to training record management. This includes establishing clear policies and procedures, investing in appropriate technology for record keeping, conducting regular internal audits, and fostering a culture of continuous improvement in safety and compliance. The decision-making framework should always weigh the potential risks to public safety and regulatory standing against the proposed solutions, ensuring that the chosen method is both efficient and compliant. Question 4. Benchmark analysis indicates that a commercial driver is preparing to transport a shipment of hazardous materials. The driver has received the shipping papers and observed the packaging and vehicle. Which of the following actions demonstrates the most comprehensive adherence to federal regulations? CFR 49 Parts 100-180 for ensuring the safe and legal transport of these materials. Option A. Proceeding with the shipment if the primary hazard class is correctly identified on the shipping papers, assuming minor discrepancies in secondary hazards or packaging details are acceptable for expediency. Option B. Visually inspecting the packaging for any obvious signs of damage and ensuring the driver's hazardous materials endorsement is current, without a detailed review of the shipping paper specifics or placarding. Option C. Confirming the shipping papers accurately list the proper shipping name, UN identification number, hazard class, and packing group, and verifying that the vehicle is placarded correctly for the materials being transported, while also ensuring the packaging appears intact and appropriate for the hazard. Option D. Relying on the shipper's assurance that all documentation and packaging are in order, as they are the experts in preparing hazardous materials for transport. The correct answer is C. Confirming the shipping papers accurately list the proper shipping name, UN identification number, hazard class, and packing group, and verifying that the vehicle is placarded correctly for the materials being transported, while also ensuring the packaging appears intact and appropriate for the hazard. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a driver to interpret and apply complex federal regulations, CFR 49 Parts 100-180, in real time to ensure the safe and legal transport of hazardous materials. Misinterpreting or overlooking specific requirements can lead to severe consequences, including environmental damage, injury, or death, and significant legal penalties for both the driver and the employing company. The driver must possess a thorough understanding of classification, packaging, labeling, placarding, and shipping paper requirements. Correct approach analysis. The correct approach involves meticulously verifying that all aspects of the hazardous material shipment comply with the specific requirements outlined in CFR 49 Parts 100-180. This includes confirming the correct hazard class and division, ensuring the proper shipping name and UN identification number are accurately listed on the shipping papers, and that the packaging is authorized and in good condition. Furthermore, it requires verifying that the vehicle is correctly placarded according to the materials being transported, and that the driver possesses the necessary endorsements and training. This approach represents best professional practice because it directly adheres to the regulatory framework designed to prevent incidents and protect public safety. It demonstrates a commitment to compliance, risk mitigation, and responsible hazardous materials management. Incorrect approaches analysis. One incorrect approach would be to assume that, because a material is commonly transported, standard procedures are sufficient without specific verification. This fails to acknowledge that regulations can be nuanced and that specific materials may have unique requirements regarding packaging, quantity limitations, or segregation. This approach is a regulatory failure because it bypasses the due diligence mandated by CFR 49 Parts 100-180, which requires specific confirmation for each shipment. Another incorrect approach would be to rely solely on the shipper's documentation without independent verification of compliance. While shippers have responsibilities, the driver is ultimately responsible for ensuring the safe and legal transport of the hazardous materials on their vehicle. Overlooking this responsibility is a critical regulatory and ethical failure, as it abdicates the driver's duty of care and could lead to the transport of non-compliant or unsafe shipments. A third incorrect approach would be to prioritize speed or convenience over regulatory adherence, such as proceeding with a shipment where placarding is incomplete or incorrect. This is a direct violation of placarding requirements under CFR 49 Parts 100-180 and creates an immediate safety hazard by failing to adequately inform emergency responders of the nature of the materials being transported. This is a severe regulatory and ethical failure, demonstrating a disregard for safety and legal obligations. Professional reasoning. Professionals should employ a systematic checklist approach when handling hazardous materials. This involves 1. Confirming the material's classification and UN number against the Hazardous Materials Table, HMT. 2. Verifying the shipping paper details match the material and are complete and accurate. 3. Inspecting the packaging for damage and ensuring it is authorized for the material and mode of transport. 4. Confirming correct placarding on the vehicle. 5. Ensuring the driver has the appropriate endorsements and training. If any discrepancy is found, the professional must address it with the shipper or refuse the shipment until compliance is achieved. This structured process ensures all regulatory requirements are met, minimizing risk and upholding professional responsibility. Question 5. Cost-benefit analysis shows that using a slightly less robust but significantly cheaper type of drum for transporting a Class 3 flammable liquid might save the company substantial funds over a year. However, this alternative drum has not undergone the full UN performance testing and marking process required for such materials. What is the most appropriate course of action for the hazardous materials carrier? Option A. Utilize the cheaper drums, assuming they will likely withstand normal transportation conditions, and the cost savings outweigh the minimal perceived risk. Option B. Reuse previously used but visually intact drums that are not specifically marked for this hazardous material, as this is a common practice for cost reduction. Option C. Reject the cheaper drums and procure packaging that is fully UN performance tested and marked, as required by the Hazardous Materials Regulation. To ensure safe containment, Option D. Attempt to modify the cheaper drums to meet the performance standards, without official testing or certification, to achieve both cost savings and perceived compliance. Correct answer is A. Utilize the cheaper drums, assuming they will likely withstand normal transportation conditions, and the cost savings outweigh the minimal perceived risk. Explanation. Scenario analysis. This scenario presents a common challenge for hazardous materials transporters, balancing operational efficiency and cost savings with the paramount requirement of safety and regulatory compliance. The temptation to use less robust, cheaper packaging materials can be significant, especially when dealing with bulk shipments. However, the inherent risks associated with hazardous materials demand a rigorous adherence to packaging standards designed to prevent leaks, spills, and dangerous reactions. The professional challenge lies in recognizing that cost savings achieved through non-compliant packaging are illusory, as they can lead to catastrophic environmental damage, severe injuries or fatalities, and substantial legal and financial penalties that far outweigh any initial savings. Correct approach analysis. The correct approach prioritizes the integrity and performance of the packaging as dictated by the Hazardous Materials Regulations, HMR, found in 49 CFR. This involves selecting packaging materials and construction that meet or exceed the specific performance standards for the particular hazardous material being transported. The HMR mandates that packaging must be capable of withstanding the ordinary rigors of transportation, including vibration, changes in temperature and humidity, and shock. Using UN performance-tested and marked packaging, or packaging that meets equivalent DOT specifications, is crucial. This approach represents best professional practice because it directly aligns with the regulatory framework's intent to ensure the safe containment of hazardous materials and prevent incidents. Ethically, it upholds the responsibility to protect public safety and the environment. Incorrect approach is analysis. One incorrect approach involves opting for packaging that appears similar to compliant options, but lacks the necessary UN performance testing or DOT specification markings. This is a regulatory failure because the HMR requires specific performance standards to be met and documented, not just a superficial resemblance to approved packaging. Ethically, it demonstrates a disregard for established safety protocols and a willingness to gamble with public safety for perceived cost benefits. Another incorrect approach is to reuse packaging that has previously contained hazardous materials without reconditioning or testing it to ensure it still meets the original specifications. This is a regulatory failure because the HMR often specifies conditions for reuse, including inspection and reconditioning, to ensure the packaging's integrity is maintained. Reusing damaged or compromised packaging significantly increases the risk of failure during transport. Ethically, it shows negligence, and a failure to exercise due diligence in ensuring the safety of the shipment. A third incorrect approach is to substitute materials in the construction of a hazardous materials package with less expensive alternatives that have not been tested or approved for compatibility with the specific hazardous material. This is a critical regulatory failure, as material compatibility is a fundamental aspect of hazardous materials packaging design and testing. Incompatible materials can degrade, react, or fail, leading to containment breaches. Ethically, this demonstrates a profound lack of understanding or willful disregard for the scientific principles underlying safe hazardous materials containment. Professional reasoning. Professionals in the hazardous materials transportation industry must adopt a risk-based decision-making process that places regulatory compliance and safety at the forefront. When considering packaging, the primary question should be, does this packaging meet all applicable HMR requirements for this specific material and mode of transport? And has it been properly tested and marked to demonstrate this compliance? Cost considerations should only be evaluated after these fundamental safety and regulatory questions have been definitively answered in the affirmative. Professionals should consult the HMR, relevant industry standards, and packaging manufacturer specifications. If there is any doubt about the suitability or compliance of packaging, it is imperative to seek expert advice or choose alternative, demonstrably compliant options, even if they are more expensive. Question 6. Strategic planning requires a thorough understanding of the specific requirements for transporting hazardous materials. A commercial driver is tasked with transporting a shipment of a specific chemical classified under UN 2789, which falls under Hazard Class 8, corrosive. The shipping papers indicate a packaging group of Roman II. The driver observes that the drums provided for the shipment are robust and appear to be suitable for corrosive materials. However, they are unsure if the observed robustness directly correlates with the assigned packaging group Roman II requirement. What is the most critical factor the driver must consider to ensure compliance and safety for this shipment? Option A. Assuming that any container suitable for Hazard Class 8 will automatically meet the requirements for packaging group Roman II. Option B. Verifying that the packaging is specifically authorized by the Hazardous Materials Regulations, HMR, for UN 2789 and meets the performance standards for packaging group Roman II. Option C. Relying on the visual assessment of the drum strength and the fact that it is designed for corrosive materials. Option D. Prioritizing the use of the most cost-effective packaging available that is labeled for hazardous materials. The correct answer is B. Verifying that the packaging is specifically authorized by the Hazardous Materials Regulations, HMR, for UN 2789 and meets the performance standards for packaging group Roman II. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a critical decision regarding the packaging of hazardous materials that directly impacts public safety and regulatory compliance. Misinterpreting or misapplying packaging group requirements can lead to severe consequences, including accidents, environmental damage, and significant legal penalties. The driver, as the last line of defense, must possess a thorough understanding of these requirements to ensure safe transport. Correct approach analysis. The correct approach demonstrates best professional practice by prioritizing adherence to the specific regulatory framework governing hazardous materials transportation. This involves consulting the Hazardous Materials Regulations, HMR, and understanding how packaging groups are assigned based on the degree of danger a substance presents. The HMR specifies that packaging groups I, Roman II, and Roman III indicate high, medium, and low danger, respectively, and dictate the strength and performance standards of the packaging used. Selecting packaging that meets or exceeds the requirements for the assigned packaging group is a non-negotiable aspect of safe and legal hazardous materials transport. This approach ensures that the packaging is robust enough to contain the material under normal transportation conditions, and in the event of an incident, thereby protecting the public and the environment. Incorrect approach is analysis. An approach that relies solely on the visual appearance of the container or the general hazard class without considering the specific packaging group is a significant regulatory failure. The hazard class provides a broad categorization, but the packaging group refines this by indicating the *degree* of danger, which directly influences packaging specifications. Ignoring the packaging group means the chosen container might not be sufficiently protective for a highly dangerous substance within that class, leading to a potential breach and release. Another incorrect approach is to assume that any container labeled for hazardous materials is automatically suitable. This overlooks the critical requirement for packaging to be tested and certified to meet specific performance standards aligned with the substance's packaging group. Using uncertified or inappropriate packaging is a direct violation of the HMR and creates an unacceptable risk. Finally, an approach that prioritizes cost or convenience over regulatory compliance is ethically and legally unsound. While efficiency is important in logistics, it can never supersede safety and legal obligations when transporting hazardous materials. Choosing cheaper, less robust packaging that does not meet the packaging group requirements is a direct abdication of responsibility and a failure to uphold professional standards. Professional reasoning. Professionals in hazardous materials transport must adopt a systematic decision-making process. This begins with accurately identifying the hazardous material and its specific UN number. Next, they must consult the Hazardous Materials Table, HMT, in the HMR to determine the assigned hazard class, division, and, crucially, the packaging group. Once the packaging group is identified, the regulations specify the types of packaging authorized and the performance standards they must meet. This involves referencing sections of the HMR that detail packaging requirements for each packaging group. If there is any ambiguity, consulting with a certified hazardous materials specialist or the manufacturer of the packaging is essential. The overarching principle is to always err on the side of caution and ensure full compliance with the HMR to guarantee the safety of the transport operation. Question 7. Operational review demonstrates that a commercial driver is tasked with transporting a shipment of hazardous materials from the United States into Canada. The driver has a valid commercial driver's license with a hazardous materials endorsement issued under U.S. Department of Transportation (DOT) regulations. When preparing for this international transit, which regulatory framework should the driver prioritize to ensure compliance and safety upon entering Canadian territory? Option A. The driver should attempt to merge the requirements of the U.S. DOT hazardous materials regulations with the Canadian Transportation of Dangerous Goods (TDG) regulations in a way they deem most appropriate for the transit. Option B. The driver should only adhere to the regulations of the originating country, United States, because their driver's license and endorsements are issued under those laws. Option C. The driver must comply with the regulations of the destination country, Canada, and any applicable international agreements governing the cross-border transport of hazardous materials, in addition to the originating country's regulations, for the portion of the journey within the U.S. Option D. The driver can continue to operate solely under the U.S. DOT hazardous materials regulations for the entire journey, as their CDL with hazmat endorsement is internationally recognized. The correct answer is C. The driver must comply with the regulations of the destination country, Canada, and any applicable international agreements governing the cross-border transport of hazardous materials, in addition to the originating country's regulations for the portion of the journey within the U.S. Explanation. Scenario analysis. This scenario presents a professional challenge because a commercial driver transporting hazardous materials must navigate potentially conflicting regulatory requirements when crossing international borders. Misinterpreting or failing to adhere to the correct set of regulations can lead to severe consequences, including shipment delays, fines, accidents, and legal liabilities. The driver's responsibility extends beyond simply knowing the rules. It involves actively identifying and applying the appropriate framework based on the operational context. Correct approach analysis. The correct approach is to meticulously identify and comply with the regulations of the destination country, as well as any international agreements that govern the transport of hazardous materials between the two nations. This aligns with the principle of extraterritoriality in international law, where a country's laws can apply to activities occurring outside its borders if those activities have an effect within its territory or are subject to international treaties. For hazardous materials, this means understanding that while domestic regulations, e.g., U.S. DOT regulations, apply within the originating country, the destination country's specific hazardous materials transportation laws, and any relevant international modal regulations, like ADR for road transport in Europe or IMG code for maritime, become paramount once the border is crossed. This ensures the highest standard of safety and compliance is met for the entire transit. Incorrect approach is analysis. One incorrect approach is to assume that domestic regulations are sufficient for international transport. This fails to acknowledge that each country has sovereign authority over its own territory and can impose its own safety and environmental standards. Relying solely on domestic rules when entering another jurisdiction is a direct violation of that country's laws and international agreements, leading to potential penalties and safety risks. Another incorrect approach is to only consider the regulations of the originating country and ignore any international agreements. International agreements, such as those facilitated by the United Nations Economic Commission for Europe, UNES, for road transport ADR, are designed to harmonize regulations across borders to facilitate safe and efficient international trade. Ignoring these can lead to noncompliance with specific requirements for placarding, documentation, packaging, or driver training that are mandated by these international frameworks. A third incorrect approach is to apply a blend of regulations without a clear understanding of which takes precedence. This haphazard application can result in overlooking critical requirements from either the domestic or international framework, creating significant compliance gaps. For instance, a driver might incorrectly assume a U.S. placarding requirement is acceptable in Canada without verifying Canadian or international modal requirements, which could be different and more stringent. Professional reasoning. Professionals in hazardous materials transportation must adopt a proactive and diligent approach. This involves 1. Pre-trip planning, thoroughly researching the specific hazardous materials being transported and the route, including all border crossings. 2. Regulatory identification, determining which domestic regulations apply in the originating country and which international regulations and destination country-specific regulations will apply once crossing borders. This includes identifying the relevant modal regulations, road, rail, air, sea. 3. Documentation verification, ensuring all shipping papers, manifests, and emergency response information comply with the requirements of all applicable jurisdictions and international agreements. 4. Equipment and placarding, confirming that vehicle placarding, marking, and equipment meet the most stringent requirements of all jurisdictions involved in the transit. 5. Driver training, ensuring the driver has received appropriate training for both domestic and international hazardous materials transport, including any specific endorsements or certifications required. 6. Continuous monitoring, staying informed about any updates or changes to relevant regulations. Question 8. Regulatory review indicates a commercial motor vehicle is transporting multiple hazardous materials. The driver has reviewed the shipping papers and identified the presence of Class 3 flammable liquids and Class 8 corrosives. The driver is unsure if placarding is required for both hazard classes, as the quantities of each material are below the maximum allowable for a single placarded load, but are significant. Based on the U.S. Department of Transportation Hazardous Materials Regulations, what is the correct determination regarding placarding for this vehicle? Option A. The driver should only placard for the hazard class that represents the highest risk, as determined by their personal assessment of the materials. Option B. The driver should consult the regulations for placarding requirements, but only if the total gross weight of all hazardous materials exceeds a general threshold, not on a per-hazard class basis. Option C. The driver should assume placarding is required for all hazardous materials being transported, regardless of quantity, to ensure maximum visibility of potential hazards. Option D. The driver must determine if the quantity of each individual hazard class meets or exceeds the specified placarding thresholds outlined in the regulations, and placard for all applicable hazard classes if those thresholds are met. Correct answer is D. The driver must determine if the quantity of each individual hazard class meets or exceeds the specified placarding thresholds outlined in the regulations, and placard for all applicable hazard classes if those thresholds are met. Explanation. This scenario is professionally challenging because it requires a driver to interpret and apply complex placarding regulations based on the specific hazardous materials being transported and their quantities, without direct supervision. Misinterpreting these requirements can lead to significant safety risks, including inadequate hazard communication to emergency responders and the public, and potential regulatory penalties. Careful judgment is required to ensure compliance with the Hazardous Materials Regulations, HMR, as defined by the U.S. Department of Transportation. The correct approach represents best professional practice because it directly aligns with the core purpose of placarding, to provide immediate, visible identification of the hazards present on a transport vehicle. By correctly identifying the hazard classes and determining if the quantity thresholds for placarding are met, the driver ensures that emergency personnel can quickly assess the risks and respond appropriately in the event of an incident. This proactive compliance with DOT regulations is paramount for public safety and avoids legal repercussions. An incorrect approach that involves assuming placarding is always required for any amount of a hazardous material is a failure of regulatory understanding. The HMR specifies quantity thresholds for many materials, and placarding is not universally mandated for all quantities. This assumption could lead to unnecessary placarding, potentially causing confusion, or it could lead to a failure to placard when required if the driver incorrectly believes a material is exempt due to quantity. Another incorrect approach, such as only placarding based on the driver's personal assessment of risk, without consulting the specific regulations for each material and its quantity, represents a significant ethical and regulatory failure. The HMR provides a clear, objective standard for placarding. Relying on subjective judgment bypasses these established safety protocols and can result in either over-placarding, causing confusion, or under-placarding, failing to warn of genuine hazards. This demonstrates a lack of diligence and a disregard for the established legal framework designed to protect public safety. A further incorrect approach, such as placarding only the highest hazard class present and ignoring others, is also a regulatory failure. The HMR requires placarding for all applicable hazard classes and divisions when the specified quantity thresholds are met. Failing to placard for all relevant hazards provides an incomplete picture of the risks, hindering effective emergency response. The professional decision-making process for similar situations should involve a systematic review of the shipping papers and the specific hazardous materials being transported. The driver must then consult the relevant sections of the Hazardous Materials Regulations, 49 CFR, to determine the correct hazard class, ES, and any applicable quantity limitations for placarding. If the quantity of any hazardous material meets or exceeds the specified thresholds for its hazard class, the appropriate placards must be displayed on the vehicle. This process emphasizes adherence to established regulations over personal interpretation or assumptions. Question 9. Cost-benefit analysis shows that using a generic placard for a shipment of isopropyl alcohol, a known Class 3 flammable liquid, could save time and reduce administrative burden. However, the driver is aware that isopropyl alcohol has specific flash point and vapor pressure characteristics that define its flammability hazard. Given the absolute priority of regulatory compliance for hazardous materials transportation, which of the following actions best upholds the driver's responsibilities under U.S. DOT hazardous materials regulations? Option A. Rely on the shipper's assurance that the material is safely packaged and proceed without detailed verification of the placard. Option B. Use a generic dangerous placard if the shipment contains multiple hazardous materials, as this is often accepted for mixed loads. Option C. Ensure the vehicle is placarded as Class 3 flammable liquid, matching the known properties of isopropyl alcohol, and verify this against the shipping papers. Option D. Apply a placard for a less hazardous class if the material is not actively leaking or emitting fumes, assuming a lower risk profile. The correct answer is C. Ensure the vehicle is placarded as Class 3 flammable liquid, matching the known properties of isopropyl alcohol, and verify this against the shipping papers. Explanation. Scenario analysis. This scenario is professionally challenging because it requires a driver to make a critical decision under pressure, balancing operational efficiency with absolute adherence to safety regulations for hazardous materials. Misclassification or improper handling of hazardous materials can lead to severe accidents, environmental damage, and significant legal repercussions. The driver's judgment directly impacts public safety and the integrity of the transportation operation. Correct approach analysis. The correct approach involves meticulously identifying the hazardous material based on its inherent properties and the information provided on the shipping papers and placards. This aligns with the core principles of the Hazardous Materials Regulations, HMR, under the U.S. Department of Transportation. Specifically, understanding the characteristics of Class 3 flammable liquids is paramount. Class 3 materials are defined by their flash point and boiling point, and their primary hazard is flammability. Proper identification ensures the correct placarding, segregation, and emergency response information are utilized, minimizing the risk of ignition or uncontrolled burning. This approach represents best professional practice by prioritizing safety and regulatory compliance above all else, as mandated by 49 CFR Parts 171-180. Incorrect approaches analysis. One incorrect approach would be to assume the material is less hazardous based on its common use or packaging, without verifying its classification. This bypasses the regulatory requirement for accurate identification and placarding, creating a significant safety risk. For example, if a flammable liquid is mistakenly treated as a non-hazardous substance, it might be loaded near ignition sources or incompatible materials, leading to a fire. This is a direct violation of 49 CFR Section 172(300), which mandates proper placarding. Another incorrect approach would be to rely solely on the shipper's verbal assurance without cross-referencing the shipping papers and placards. While shippers are responsible for classifying materials, drivers have a legal obligation to verify this information. Verbal assurances can be prone to error or miscommunication. Failing to verify can lead to the same hazardous consequences as misclassification, violating the driver's responsibility under 49 CFR Section 177. 800. A third incorrect approach would be to prioritize speed or convenience over accurate classification, perhaps by using a generic placard for a group of materials without confirming each individual substance's specific class. This is a dangerous shortcut that ignores the detailed requirements for hazardous material identification. Each hazardous material has unique properties and associated risks that necessitate specific handling procedures. Using a generic placard for a Class 3 flammable liquid when it might have other hazards, e.g., toxicity, would be a failure to comply with 49 CFR Section 172(504), which specifies the types of placards required for different hazard classes. Professional reasoning. Professionals in hazardous materials transportation must adopt a systematic and verification-driven decision-making process. This involves 1. Thoroughly reviewing shipping papers for accurate descriptions, UN numbers, and hazard classes. 2. Visually inspecting placards on the vehicle and containers to ensure they match the shipping documents. 3. Understanding the fundamental properties and hazards associated with each DOT hazard class, explosives, gases, flammable liquids, flammable solids, oxidizers, poisons, radioactive materials, corrosives, miscellaneous. 4. Consulting the Emergency Response Guidebook, ERG, for specific guidance on handling and emergency procedures for the identified material. 5. Never proceeding with a shipment if there is any doubt or discrepancy regarding the classification or placarding. In such cases, the driver must refuse the shipment or contact the appropriate authorities or the shipper for clarification. This layered approach ensures compliance and mitigates risks. Question 10. Stakeholder feedback indicates that some commercial drivers transporting hazardous materials struggle with accurately identifying and classifying substances. When a driver encounters a material like lithium-ion batteries, dry, sealed, what is the most appropriate regulatory action to ensure proper classification and compliance with the hazardous materials regulations, HMR, in the United States? Option A. Consult the Hazardous Materials Table HMT in 49 CFR Section 172(101) to find the specific entry for lithium-ion batteries, dry, sealed, and adhere to the assigned proper shipping name, hazard class, identification number, and any associated special provisions. Option B. Classify the material based on its physical state, e.g., solid, and general knowledge of battery components, without direct reference to the HMT. Option C. Rely on the manufacturer's product label, which may list lithium-ion batteries, and use that information as the sole basis for classification and shipping documentation. Option D. Assume the material falls under Class 9, miscellaneous hazardous materials, based on its common association with electronics, and proceed with general Class 9 placarding. The correct answer is A. Consult the Hazardous Materials Table HMT in 49 CFR Section 172(101) to find the specific entry for lithium-ion batteries, dry, sealed, and adhere to the assigned proper shipping name, hazard class, identification number, and any associated special provisions. Explanation. Scenario analysis. This scenario is professionally challenging because a commercial driver transporting hazardous materials must accurately identify and classify substances to ensure compliance with stringent safety regulations. Misclassification can lead to improper placarding, packaging, and handling, creating significant risks to public safety and the environment. The driver's responsibility extends beyond simply knowing the material's name. It requires understanding its inherent hazards and corresponding regulatory requirements. Correct approach analysis. The correct approach represents best professional practice because it directly aligns with the core principles of the Hazardous Materials Regulations, HMR, as outlined by the Pipeline and Hazardous Materials Safety Administration, PHMSA in the United States. Specifically, it requires the driver to consult the Hazardous Materials Table, HMT, found in 49 CFR Section 172. 101. This table is the definitive source for classifying hazardous materials, assigning proper shipping names, hazard classes, identification numbers, and packing group assignments. By referencing the HMT, the driver ensures they are using the precise, legally mandated information for the specific substance, thereby fulfilling their regulatory obligation to properly identify and communicate the hazards. This systematic approach minimizes the risk of error and upholds the highest standards of safety. Incorrect approaches analysis. One incorrect approach involves relying solely on the common name of a substance without cross-referencing it with the HMT. This is a regulatory failure because common names can be ambiguous or may not fully encompass the hazardous properties of the material as defined by the HMR. For example, paint is a common name, but the HMT specifies different entries for flammable paints, corrosive paints, or other hazardous paint-related materials, each with distinct requirements. Another incorrect approach is to assume that material belongs to a particular class based on its general appearance or intended use. This is an ethical and regulatory failure because hazard classification is based on specific testing and criteria defined in 49 CFR Part 173. Not on subjective interpretation. For instance, a substance that appears inert might, upon closer examination or under specific conditions, fall into a more dangerous hazard class, such as a spontaneously combustible material or a water-reactive substance. A third incorrect approach is to only consider the immediate hazards and ignore potential secondary hazards or specific regulatory exceptions. This is a failure to adhere to the comprehensive nature of the HMR. The regulations account for various scenarios and specific properties that might not be immediately obvious. For example, some materials might be classified under one hazard class, but also possess properties that trigger additional handling or placarding requirements under a subsidiary hazard. Professional reasoning. Professionals in this field should employ a systematic, evidence-based decision-making process. This involves 1. Identifying the material by its shipping name or common name. 2. Consulting the Hazardous Materials Table, HMT, in 49 CFR Section 172, 101 to find the official entry for that material. 3. Verifying the assigned proper shipping name, hazard class, identification number, UN/NA number, and packing group from the HMT. 4. Reviewing any special provisions or requirements listed in the HMT or other relevant sections of the HMR, e.g., 49 CFR Part 173 for packaging and hazard class definitions. 5. Ensuring all documentation, placarding, and vehicle safety equipment correspond precisely to the information derived from the HMT and other regulatory requirements. This structured approach ensures accuracy, compliance, and the highest level of safety. Question 11. Implementation of procedures for an unattended hazardous materials vehicle requires a driver to make critical decisions. If a commercial driver discovers a hazardous materials vehicle they are responsible for is unattended and the doors are ajar, what is the most appropriate immediate course of action to ensure safety and regulatory compliance? Option A. Continue with the scheduled delivery route, assuming the situation is not an immediate threat and the vehicle is secure enough to proceed. Option B. Immediately contact the appropriate authorities, such as the National Response Center or local emergency services, and remain at a safe distance until they arrive. Option C. Attempt to secure the vehicle by closing the doors and waiting for the authorized driver to return, as they may have only stepped away briefly. Option D. Leave the scene immediately to avoid any potential involvement, and report the incident later when convenient. The correct answer is B. Immediately contact the appropriate authorities, such as the National Response Center or local emergency services, and remain at a safe distance until they arrive. Explanation: the scenario of an unattended hazardous materials vehicle presents a significant professional challenge due to the inherent risks associated with the cargo. The primary concern is the potential for unauthorized access, theft, or accidental release of hazardous substances, which could lead to severe environmental damage, public health crises, and significant financial and legal repercussions for the driver and the employing company. Careful judgment is paramount to ensure public safety and regulatory compliance. The correct approach, which involves immediately notifying the proper authorities and remaining at a safe distance while awaiting their arrival, represents best professional practice because it directly aligns with federal regulations for hazardous materials transportation. Specifically, it adheres to the requirements outlined in the U.S. Department of Transportation's Hazardous Materials Regulations, HMR, which mandate immediate reporting of incidents and unauthorized access to hazardous materials shipments. This action prioritizes safety by preventing further unauthorized interaction with the vehicle and ensures that trained emergency responders can manage the situation effectively and according to established protocols. Ethically, it demonstrates a commitment to public welfare and responsible stewardship of hazardous materials. An incorrect approach of attempting to secure the vehicle oneself without proper training or authorization is professionally unacceptable. This action poses a direct regulatory failure by potentially violating HMR provisions that restrict who can handle hazardous materials and under what conditions. It also creates an ethical failure by potentially exacerbating the situation, leading to personal injury or a more widespread incident, thereby failing to protect the public. Another incorrect approach, such as leaving the scene entirely without reporting, constitutes a severe regulatory violation of reporting requirements and an ethical breach of duty of care. This abandons responsibility and leaves the public vulnerable to potential hazards. Finally, an incorrect approach of assuming the situation is not serious and continuing with the delivery schedule without proper assessment and reporting is a critical regulatory and ethical failure. It disregards the inherent risks of hazardous materials and prioritizes commercial expediency over safety and compliance. Professionals should employ a decision-making framework that begins with immediate risk assessment. Upon encountering an unattended hazardous materials vehicle, the first step is to determine if the situation poses an immediate threat. If so, maintaining a safe distance is crucial. The next step is to consult the emergency response information, ERI, provided with the shipment, which will guide the driver on appropriate actions and contact information. The core of the decision-making process must then involve immediate and accurate reporting to the designated authorities, such as the National Response Center, NRC, or local emergency services, as mandated by regulations. This framework emphasizes proactive safety measures, adherence to regulatory mandates, and responsible crisis management. Question 12. Strategic planning requires a commercial driver transporting a shipment of corrosive materials to ensure the vehicle is properly placarded. The driver has a general understanding that corrosives require a specific placard, but is unsure if any subsidiary hazards are present for this particular shipment that would necessitate additional placarding. What is the most compliant and safest course of action to determine the correct placarding requirements? Option A. Rely on prior experience with similar shipments to determine the appropriate placard without needing to re-verify the shipping papers. Option B. Apply placards for both corrosive materials and a common subsidiary hazard like flammable liquid, as it is better to over-communicate potential risks. Option C. Consult the Hazardous Materials Regulations, HMR, and the vehicle's shipping papers to identify the primary hazard class and any required subsidiary hazard placards for the specific materials being transported. Option D. Assume the standard placard for corrosive materials is sufficient, as the primary hazard is the most critical to communicate. The correct answer is C. Consult the Hazardous Materials Regulations, HMR, and the vehicle's shipping papers to identify the primary hazard class and any required subsidiary hazard placards for the specific materials being transported. Explanation: this scenario presents a professional challenge because it requires a driver to make a critical decision regarding hazardous materials placarding under pressure, with potential safety and regulatory consequences. The driver must accurately identify the hazard class and subsidiary risks of the cargo to ensure correct placarding, which is essential for emergency responders to quickly understand the risks involved in an incident. Failure to placard correctly can lead to inappropriate response actions, increased danger to the public and emergency personnel, and significant regulatory penalties. The correct approach represents best professional practice because it prioritizes safety and regulatory compliance above all else. By consulting the Hazardous Materials Regulations, HMR, and the vehicle's shipping papers to confirm the correct placard for the primary hazard class, the driver is adhering to the established legal framework designed to mitigate risks associated with transporting hazardous materials. This meticulous attention to detail ensures that emergency responders have accurate information, thereby protecting lives and property. An incorrect approach involving the assumption of placarding based on general knowledge of a commodity, without verifying against the shipping papers and HMR, is a significant regulatory and ethical failure. This bypasses the established safety protocols and relies on potentially incomplete or outdated information, which is unacceptable when dealing with hazardous materials. Another incorrect approach, such as placarding for a subsidiary hazard when it is not required by regulation for that specific shipment, can lead to unnecessary alarm and misallocation of resources by emergency responders, creating a different but equally dangerous situation. Finally, failing to placard at all or using a placard for a different hazard class constitutes a direct violation of the HMR, demonstrating a severe disregard for safety and legal obligations. Professionals should employ a decision-making framework that emphasizes a systematic and compliant approach. This involves 1. Thoroughly reviewing shipping papers to identify the specific hazardous materials being transported and their assigned hazard classes. 2. Consulting the HMR, specifically 49 CFR Part 172, Subpart F, to determine the correct placard, S, required for the identified hazard class E's and any applicable subsidiary risks. 3. Visually inspecting the vehicle to ensure the correct placards are displayed on all four sides in the designated locations and are legible. 4. If any doubt or ambiguity arises, the driver must seek clarification from the shipper or carrier before proceeding. This process ensures that all regulatory requirements are met and that the highest level of safety is maintained. Question 13. Risk assessment procedures indicate that a commercial driver is transporting a chemical substance for which the shipping papers list a UN number but no explicit hazard class or division. The driver recalls transporting a similar-looking substance previously that was classified as a Class 3 flammable liquid. Which of the following actions best ensures compliance with the Hazardous Materials Regulations, HMR, and promotes safety? Option A. Consult the Hazardous Materials Table, HMT, in 49 CFR Section 172, 101, using the provided UN number to determine the official hazard class and division. Option B. Assume the substance is a Class 3 flammable liquid based on prior experience with a similar-looking material. Option C. Rely on the general appearance of the chemical to infer its hazard class and division. Option D. Ask a fellow driver who has transported similar chemicals for their opinion on the correct hazard classification. Correct answer is A. Consult the Hazardous Materials Table, HMT, in 49 CFR Section 172, 101, using the provided UN number to determine the official hazard class and division. Explanation. Scenario analysis. This scenario is professionally challenging because a commercial driver transporting hazardous materials must accurately identify and understand the risks associated with each substance. Misidentification or misunderstanding of hazard classes can lead to improper handling, placarding, segregation, and emergency response, potentially resulting in severe accidents, environmental damage, and harm to the public and the driver. The driver's judgment is critical in ensuring compliance and safety. Correct approach analysis. The correct approach involves consulting the Hazardous Materials Regulations, HMR, to determine the specific hazard class and division for the substance. This is best professional practice because the HMR provides the definitive classification for hazardous materials in the United States. Accurate classification dictates all subsequent safety requirements, including packaging, labeling, placarding, shipping papers, and emergency response information. Adhering to the HMR ensures compliance with federal law and promotes the highest level of safety. Incorrect approach is analysis. One incorrect approach is to rely on the general appearance or common name of the substance. This is a regulatory failure because common names can be misleading, and the appearance does not always correlate with the inherent hazards. The HMR mandates specific classifications based on scientific properties and potential risks, not subjective observations. Ethically, this approach disregards the driver's responsibility to ensure public safety. Another incorrect approach is to assume the hazard class based on previous experience with similar-looking materials. This is a regulatory failure because even slight variations in composition or concentration can place a substance into a different hazard class or division, requiring different safety protocols. Over-reliance on past experience without verification can lead to critical errors. Ethically, it demonstrates a lack of due diligence and a potential disregard for the unique risks of the current shipment. A third incorrect approach is to ask a colleague for their opinion without consulting the official regulations. This is a regulatory failure because while colleagues may have experience, their interpretation might be incorrect or outdated. The HMR is the authoritative source, and relying on informal advice bypasses the established legal framework for hazardous materials transportation. Ethically, it shifts responsibility away from the driver and potentially disseminates incorrect safety information. Professional reasoning. Professionals in this situation should follow a systematic decision-making process. 1. Identify the substance. Obtain the exact name and any identifying numbers e.g. UN number from the shipping papers or the material itself. 2. Consult authoritative sources. Immediately refer to the U.S. Department of Transportation's Hazardous Materials Regulations, 49 CFR Parts 100-185, specifically the Hazardous Materials Table, HMT, in Section 172. 101. To find the official classification, hazard class, division, packing group, and any special provisions. 3. Verify information. Cross-reference information if necessary, but always prioritize the HMT. 4. Apply regulations. Based on the confirmed classification, implement all required safety measures for placarding, labeling, packaging, segregation, and emergency response. 5. Document. Ensure all shipping papers accurately reflect the classified hazardous material. Question 14. The control framework reveals that the Hazardous Materials Regulations, HMR, present critical information in a tabular format, with specific column headings guiding the safe transport of hazardous materials. A commercial driver encounters a shipment where the shipping paper lists UN 1203, gasoline 3, PG Roman 2. Which of the following interpretations best demonstrates a comprehensive understanding of the essential information conveyed by these column headings for safe and compliant transportation? Option A. The material is a Class 3 hazard and the name gasoline is a general description. Option B. The material is gasoline and the number 1203 indicates its hazard level. Option C. The material is gasoline, identified by UN 1203, and it belongs to Hazard Class 3 with a Packing Group Roman 2 designation. Option D. The material is UN 1203, which is the primary identifier, and the other details are secondary. The correct answer is C. The material is gasoline, identified by UN 1203, and it belongs to Hazard Class 3 with a Packing Group Roman 2 designation. Explanation. The control framework reveals that understanding the column headings within the Hazardous Materials Regulations, HMR, is paramount for safe and compliant transportation of hazardous materials. This scenario is professionally challenging because a driver must accurately interpret and apply information from multiple, interconnected columns to ensure proper handling, placarding, and documentation. Misinterpreting any of these columns can lead to severe safety risks, environmental damage, and significant legal penalties. The correct approach represents best professional practice because it demonstrates a thorough understanding of the HMR's structure and the specific information each column provides, specifically correctly identifying the proper shipping name, PSN, from column 1, the hazard class/division from column 3, and the UN/NA identification number from column 4 is fundamental. This ensures the material is correctly classified, communicated, and handled according to its inherent risks. Adhering to the packaging requirements outlined in column 7, as referenced by the HMR, is also critical for preventing leaks and releases. This systematic approach ensures all regulatory requirements are met, prioritizing safety and compliance. An incorrect approach that focuses solely on the proper shipping name without considering the hazard class/division fails to capture the inherent dangers of the material. PSN is descriptive, but the hazard class/division dictates the primary risks and necessary safety precautions. This is a regulatory failure as it bypasses a core classification requirement. Another incorrect approach that prioritizes the identification number over the PSN and hazard class is also flawed. While the ID number is a unique identifier, it must be linked to the correct PSN and hazard class to be meaningful in the context of transportation safety. Relying on the ID number alone without understanding its associated hazards is a significant safety and regulatory oversight. Finally, an approach that neglects the packaging requirements column entirely, assuming standard packaging is sufficient, is a critical failure. Column 7 provides specific instructions for safe containment, and deviation from these requirements can lead to catastrophic failures. Professional decision-making in such situations requires a systematic, column-by-column analysis of the shipping paper. The driver must first locate the hazardous material entry, then meticulously extract and cross-reference information from the relevant columns. Proper shipping name, hazard class/division, identification number, and packaging group/requirements. This ensures a holistic understanding of the material's hazards and the regulatory mandates for its transportation. Question 15. Investigation of a CDL driver with a hazmat endorsement approaching a railroad crossing equipped with flashing lights and gates. What is the most critical procedural step to ensure compliance with hazardous materials regulations? Option A. Stop the vehicle at least 15 feet from the nearest rail, open the door, and listen for an approaching train before proceeding if the crossing is clear. Option B. Proceed cautiously if the warning lights are flashing, but no train is immediately visible. Option C. Honk the horn to alert any potential train of the vehicle's presence. Option D. Rely on the automatic gate to prevent entry if it is down. The correct answer is A. Stop the vehicle at least 15 feet from the nearest rail, open the door, and listen for an approaching train before proceeding if the crossing is clear. Explanation. This scenario is professionally challenging because it requires a commercial driver's license, CDL, holder with a hazardous materials, hazmat endorsement to make a critical safety decision at a railroad crossing, balancing the need for thorough inspection with the efficient flow of traffic. The driver's primary responsibility is the safe transport of hazardous materials, which necessitates strict adherence to all safety regulations, especially those pertaining to railroad crossings. The correct approach represents best professional practice because it directly aligns with the stringent safety protocols mandated by the U.S. Department of Transportation for hazmat carriers at railroad crossings. Specifically, 49 CFR Section 392(10) outlines the procedures for a commercial motor vehicle transporting hazardous materials to stop, look, and listen at all grade crossings. This regulation emphasizes a complete stop, opening the door, and listening for an approaching train. The driver must also ensure the crossing is clear before proceeding. This meticulous process minimizes the risk of a catastrophic accident involving a train and a vehicle carrying dangerous substances, thereby upholding the highest ethical and legal standards for hazmat transportation. An incorrect approach that involves proceeding without a complete stop and visual/auditory confirmation of safety is a direct violation of 49 CFR Section 392(10). This failure constitutes a significant regulatory breach and an ethical lapse, as it prioritizes speed or convenience over the absolute safety of the driver, the public, and the environment. Another incorrect approach, such as relying solely on the presence of warning lights or gates without performing the required stop and sensory checks, demonstrates a lack of due diligence and an underestimation of the potential dangers. This disregard for established safety procedures can lead to severe consequences, including accidents, fines, and license revocation. Professional decision-making in such situations should follow a clear framework. First, identify the regulatory requirements specific to the cargo and the location, in this case, hazmat and a railroad crossing. Second, assess the immediate environment for any potential hazards. Third, execute the prescribed safety procedures without deviation. Finally, confirm that all safety checks are complete and the path is clear before proceeding. This systematic approach ensures compliance and prioritizes safety above all else. Question 16. What factors determine the required retention period and accessibility of shipping papers for hazardous materials after a delivery has been completed by a commercial motor vehicle driver? Option A. The driver's personal preference for document organization and the convenience of the company's main office. Option B. The discretion of the local law enforcement officer during an inspection and the driver's memory of the shipment details. Option C. The immediate need for the papers by the consignee and the driver's desire to clear out their vehicle. Option D. The specific duration mandated by the Hazardous Materials Regulations, HMR, for motor carriers and the requirement for them to be readily accessible to authorized personnel. The correct answer is D. The specific duration mandated by the Hazardous Materials Regulations, HMR, for motor carriers and the requirement for them to be readily accessible to authorized personnel. Explanation. Scenario analysis. This scenario is professionally challenging because it involves a routine inspection that could lead to significant penalties if documentation requirements are not met. The driver's responsibility for maintaining accurate and accessible shipping papers, even after the immediate delivery, is a critical aspect of hazardous materials transportation safety and regulatory compliance. The challenge lies in understanding the precise duration and conditions under which these documents must be retained, as failure to do so can result in fines and operational disruptions. Correct approach analysis. The correct approach is to retain shipping papers for the required period after delivery, as mandated by federal regulations. This ensures that in the event of an incident, accident, or inspection, law enforcement and emergency responders have immediate access to vital information about the hazardous materials being transported. This practice directly supports the safe handling and emergency response protocols outlined in the Hazardous Materials Regulations, HMR, specifically those concerning the information required on shipping papers and their accessibility. It demonstrates a commitment to regulatory adherence and public safety. Incorrect approaches analysis. Retaining shipping papers only until the driver is back at the company's main office is incorrect because regulations typically require retention for a specific period after the delivery of the hazardous material, not just until the driver returns. This could leave a gap in documentation availability if an incident occurs between delivery and the driver's return. Discarding shipping papers immediately after delivery is incorrect and a direct violation of HMR. Shipping papers are essential for emergency response and regulatory oversight. Their immediate disposal deprives authorities of critical information, increasing risks in case of an incident and constituting a clear regulatory failure. Keeping shipping papers only in the vehicle's cab indefinitely is also problematic. While accessibility is key, regulations often specify a retention period and may require papers to be available at the motor carrier's principal place of business or a designated location, not solely dependent on the vehicle's presence. Furthermore, indefinite retention in a vehicle could lead to loss, damage, or inaccessibility if the vehicle is unavailable. Professional reasoning. Professionals should always prioritize understanding and adhering to the specific retention periods and accessibility requirements for shipping papers as defined by the HMR. This involves knowing the duration mandated by the regulations, e.g., 37 days after delivery for motor carriers, and ensuring that the papers are readily available to authorized personnel upon request, whether at the point of delivery, during transit, or at the carrier's facility. A proactive approach involves establishing clear internal procedures for document management and driver training on these requirements. Question 17. When evaluating potential routes for a shipment of Class 3 flammable liquids, a commercial driver must consider all applicable federal, state, and local regulations. If a U.S. DOT-designated highway route for hazardous materials is available, but a state or local ordinance imposes a more restrictive route that avoids densely populated areas, which routing principle should the driver prioritize to ensure regulatory compliance and public safety? Option A. Follow the U.S. DOT-designated highway route as it is the primary federal standard for hazardous materials. Option B. Select a route that is not explicitly prohibited by any regulation, assuming it is permissible. Option C. Choose the shortest or most convenient route that avoids obvious hazards, regardless of specific regulatory designations. Option D. Adhere to the most restrictive route that is legally mandated, whether it is a federal, state, or local designation. Correct answer is D. Adhere to the most restrictive route that is legally mandated, whether it is a federal, state, or local designation. Explanation. This scenario is professionally challenging because hazardous materials, hazmat, routing is a complex area governed by strict regulations designed to protect public safety and the environment. Drivers and carriers must navigate a web of federal, state, and local rules, which can vary significantly and often require detailed knowledge of specific routes, placarding, and emergency response information. The challenge lies in ensuring compliance while also operating efficiently, which can sometimes create tension. Careful judgment is required to balance these competing demands and avoid potentially catastrophic consequences. The correct approach represents best professional practice because it prioritizes adherence to the most restrictive applicable regulations. In the context of hazmat routing, this means consulting and following the specific route restrictions mandated by the U.S. Department of Transportation regulations, as well as any applicable state or local laws that impose additional limitations. This ensures that the driver is operating on a route that has been deemed safe for the specific type and quantity of hazardous material being transported, minimizing risks to populated areas, sensitive environments, and critical infrastructure. This proactive and compliant approach is ethically sound and legally mandated. An incorrect approach that involves disregarding specific route restrictions based on personal preference or perceived convenience is a significant regulatory and ethical failure. This directly violates DOT regulations, specifically those concerning the routing of hazardous materials, which are designed to prevent incidents in high-risk areas. Such an approach demonstrates a disregard for public safety and environmental protection, potentially leading to severe penalties, including fines, license suspension, and criminal charges. It also erodes public trust in the hazmat transportation industry. Another incorrect approach, such as relying solely on general knowledge of road conditions without consulting official routing information, is also a failure. While general knowledge might be helpful for other types of freight, hazmat transportation requires specific, documented compliance with routing requirements. This approach fails to meet the regulatory standard for due diligence and could lead to unknowingly entering prohibited areas or routes, thereby creating an unacceptable risk. Finally, an incorrect approach that involves assuming that if a route is not explicitly prohibited, it is permissible, is a dangerous misinterpretation of the regulations. Hazmat routing regulations often require drivers to follow specific designated routes or to obtain permits for deviation. The absence of an explicit prohibition does not equate to permission, especially when dealing with materials that pose a significant hazard. Professionals must actively seek out and adhere to all applicable routing requirements, not just avoid explicitly forbidden paths. The professional decision-making process for similar situations should begin with a thorough understanding of the specific hazardous material being transported and its associated risks. This understanding should then be used to consult the relevant federal regulations, e.g., 49 CFR Parts 170-180, and any applicable state or local laws governing hazmat routing. Carriers and drivers must have access to and be trained on how to use official routing guides and resources. When in doubt, seeking clarification from regulatory authorities or experienced hazmat professionals is crucial. The decision must always prioritize safety and compliance over expediency. Question 18. System analysis indicates that a commercial driver transporting hazardous materials must conduct a thorough inspection of cargo tanks and equipment. Considering the potential for catastrophic failure and the regulatory imperative for safety, which inspection approach best mitigates risk and ensures compliance with hazardous materials transportation laws? Option A. Rely exclusively on the pre-trip inspection report completed by the previous driver, without conducting an independent verification of the cargo tank's condition. Option B. Perform only a quick visual check of the cargo tank's exterior for obvious damage, assuming internal components are functioning correctly if no external issues are apparent. Option C. Conduct a risk assessment of the cargo tank and its associated equipment, prioritizing inspection of components based on their criticality to containment and potential for failure given the specific hazardous material and operating conditions. Option D. Inspect only the most visible and easily accessible parts of the cargo tank and its associated valves and fittings, overlooking less accessible areas. Correct answer is C. Conduct a risk assessment of the cargo tank and its associated equipment, prioritizing inspection of components based on their criticality to containment and potential for failure given the specific hazardous material and operating conditions. Explanation. Scenario analysis. This scenario presents a common but critical challenge in hazardous materials transportation. ensuring the integrity of cargo tanks and associated equipment. The professional challenge lies in the potential for catastrophic failure if inspections are inadequate, leading to severe environmental damage, injury, or death. A driver's responsibility extends beyond simply operating the vehicle. It includes a proactive role in safety through diligent inspection. The risk assessment approach is paramount because it requires the driver to evaluate potential hazards and prioritize inspection efforts based on the likelihood and severity of failure. Correct approach analysis. The correct approach, focusing on a risk assessment of cargo tanks and equipment, represents best professional practice because it aligns directly with the core principles of hazardous materials safety regulations. Specifically, it embodies the spirit and intent of regulations like those found in the U.S. Department of Transportation's Federal Motor Carrier Safety Administration, FMCSA, Part 383, which governs commercial driver's licenses with hazardous materials endorsements. These regulations mandate thorough pre-trip inspections, emphasizing the driver's responsibility to ensure the vehicle and its cargo are safe for transport. A risk assessment approach ensures that the driver systematically identifies potential failure points, e.g., worn seals, damaged valves, structural integrity of the tank, and prioritizes their inspection based on the specific hazardous material being transported and the operating conditions. This proactive, analytical method minimizes the likelihood of an incident by focusing attention where it is most needed, thereby upholding the ethical obligation to protect public safety and the environment. Incorrect approaches analysis. One incorrect approach involves performing only a cursory visual check without a systematic evaluation of potential failure points. This fails to meet the regulatory requirement for a thorough inspection. Ethically, it demonstrates a lack of due diligence and a disregard for the inherent risks associated with hazardous materials. Such an approach could lead to overlooking critical defects that a more structured inspection would reveal, directly violating the driver's duty of care. Another incorrect approach is to rely solely on the previous driver's inspection report without conducting an independent assessment. While previous reports are valuable, they do not absolve the current driver of their responsibility. Regulations require the driver to be satisfied with the condition of the vehicle and cargo before commencing a trip. Over-reliance on others' work is a regulatory failure and an ethical lapse, as it shifts responsibility away from the individual accountable for the immediate safety of the transport. A third incorrect approach is to only inspect components that are easily accessible or visible, neglecting less accessible but equally critical parts of the cargo tank system. This is a failure to conduct a comprehensive inspection as required by regulations. Ethically, it prioritizes convenience over safety, potentially leaving the hazardous material vulnerable to release due to defects in hidden areas. Professional reasoning. Professionals in hazardous materials transportation must adopt a systematic, risk-based approach to inspections. This involves understanding the specific hazards of the materials being transported, the design and operational characteristics of the cargo tank, and the potential failure modes of all associated equipment. When faced with an inspection task, a professional will 1. Review the manifest and understand the hazardous materials' properties and associated risks. 2. Consult the vehicle's operational manual and relevant regulatory guidance for specific inspection points. 3. Systematically examine all critical components of the cargo tank and its associated systems, prioritizing areas known to be prone to failure or those that have a direct impact on containment. 4. Document all findings thoroughly and take appropriate action if defects are identified, which may include refusing to transport the load until repairs are made. This methodical process ensures compliance, minimizes risk, and upholds the highest standards of professional conduct. Question 19. The evaluation methodology shows that a commercial driver's license holder with a hazardous materials endorsement is preparing to load a shipment of flammable liquid. The facility has a vapor recovery system in place, but the driver observes that the indicator light for the system is not illuminated, suggesting a potential malfunction. What is the most appropriate course of action to ensure compliance with U.S. hazardous materials regulations? Option A. Continue with the loading operation as scheduled, assuming the indicator light is faulty and the system is otherwise operational, as the shipper has certified the load as safe. Option B. Proceed with the loading operation only after confirming with the facility's designated safety officer that the vapor recovery system is functioning correctly, even if the indicator light remains off. Option C. Immediately halt the loading operation and refuse to proceed until the vapor recovery system is confirmed to be fully operational and the indicator light is functioning as designed. Option D. Attempt to troubleshoot the indicator light issue independently to determine if it is a minor electrical problem before proceeding with the loading. The correct answer is B. Proceed with the loading operation only after confirming with the facility's designated safety officer that the vapor recovery system is functioning correctly, even if the indicator light remains off. Explanation: this scenario is professionally challenging because it requires a commercial driver's license (CDL) holder with a hazardous materials (hazmat) endorsement to make a critical judgment call regarding the operational status of a vapor recovery system during a loading operation. The driver's primary responsibility is the safe transport of hazardous materials, which includes ensuring all safety equipment and procedures are followed to prevent releases and protect public health and the environment. Misjudging the necessity or functionality of a vapor recovery system can lead to significant environmental violations, safety hazards, and potential accidents. The correct approach represents best professional practice because it prioritizes regulatory compliance and safety by ensuring the vapor recovery system is operational and functioning as intended before commencing the loading of a hazardous material. This aligns directly with the U.S. Department of Transportation, Hazardous Materials Regulations, HMR, specifically those pertaining to loading and unloading operations and the use of safety equipment designed to mitigate vapor release. By verifying the system's functionality, the driver is actively preventing potential fugitive emissions, which are a direct violation of environmental regulations and can pose inhalation risks to personnel and the public. This proactive stance demonstrates adherence to the spirit and letter of hazmat transportation laws, which emphasize minimizing risks associated with the movement of dangerous goods. An incorrect approach that involves proceeding with the loading operation without verifying the vapor recovery system's functionality is a direct regulatory failure. This action violates the principle of ensuring all safety equipment is in proper working order before handling hazardous materials, as mandated by various sections of the HMR concerning operational safety and equipment integrity. Ethically, it represents a disregard for the potential environmental impact and the safety of others, prioritizing expediency over due diligence. Another incorrect approach, such as relying solely on the shipper's verbal assurance without independent verification, also constitutes a regulatory failure. While shippers have responsibilities, the CDL driver with a hazmat endorsement bears ultimate responsibility for the safe operation of their vehicle and the loading/unloading process as it pertains to their direct control and oversight. This failure to independently confirm critical safety systems is a breach of professional duty. The professional decision-making process for similar situations should involve a systematic checklist approach. First, the driver must be aware of all applicable regulations for the specific hazardous material being transported and the loading/unloading procedures. Second, before commencing any loading, a thorough visual inspection of all relevant equipment, including the vapor recovery system, should be performed. Third, if the system's functionality is not immediately apparent through visual inspection, the driver must actively seek confirmation of its operational status, ideally through a functional test or by consulting the site's safety protocols and personnel. Fourth, if there is any doubt about the system's functionality or compliance, the driver must refuse to proceed with the loading until the issue is resolved, escalating the concern to their supervisor or the appropriate authorities if necessary. This methodical approach ensures that safety and regulatory compliance are paramount. Question 20. The evaluation methodology shows that a commercial driver transporting hazardous materials is presented with shipping papers that list a substance with a UN number and proper shipping name. But the hazard class indicated on the papers does not align with the typical hazard class associated with that UN number and proper shipping name according to the Hazardous Materials Table, HMT. The driver also notices that the vehicle is not placarded for the hazard class listed on the shipping papers. What is the most appropriate course of action for the driver? Option A. Refuse to accept the shipment and notify the carrier and shipper of the discrepancy and potential hazard. Option B. Accept the shipment and attempt to contact the shipper for clarification while already en route. Option C. Accept the shipment and rely on personal experience to determine the actual hazard, disregarding the documentation. Option D. Accept the shipment and assume the shipper has correctly classified the material, proceeding to the destination. The correct answer is A. Refuse to accept the shipment and notify the carrier and shipper of the discrepancy and potential hazard. Explanation. Scenario analysis. This scenario is professionally challenging because it requires the driver to exercise independent judgment regarding the safety of a hazardous materials shipment, even when presented with what appears to be complete documentation. The driver is the last line of defense in preventing incidents. Misinterpreting or overlooking critical information on shipping papers, or failing to recognize potential hazards not explicitly detailed but implied by the cargo, can lead to severe consequences, including environmental damage, injury, or death. The driver must balance the need to adhere to schedules with the absolute imperative of safety, a constant tension in hazardous materials transportation. Correct approach analysis. The correct approach, which involves the driver refusing to accept the shipment due to the discrepancy and potential hazard, represents best professional practice because it directly aligns with the fundamental principles of hazardous materials regulations. Specifically, 49 CFR Part 177, 804 mandates that a driver must not transport a hazardous material unless the shipping papers are correct and complete, and the vehicle is properly placarded and marked. Furthermore, the driver has a moral and ethical obligation to ensure the safety of the public and the environment. Refusing a shipment that appears unsafe or improperly documented is a direct application of the do not proceed if unsafe principle inherent in hazardous materials transport. This proactive stance prevents potential incidents before they occur. Incorrect approach is analysis. An incorrect approach would be to accept the shipment and assume the shipper has correctly classified the material, despite the conflicting information. This fails to meet the driver's responsibility under 49 CFR Part 177. 804 to verify the accuracy and completeness of shipping papers. Ethically, it demonstrates a disregard for public safety and environmental protection by proceeding with a potentially compromised shipment. Another incorrect approach would be to accept the shipment and attempt to contact the shipper while en route. While communication is important, the primary responsibility to ensure the shipment is safe before departure rests with the driver. Delaying the refusal until after commencing transport, especially with hazardous materials, significantly increases the risk of an incident occurring on public roadways, which is a critical regulatory failure. A third incorrect approach would be to accept the shipment and rely solely on the driver's personal experience to assess the hazard, ignoring the documentation discrepancy. Hazardous materials regulations are based on specific classifications and requirements, not subjective driver interpretation. This approach bypasses the established safety protocols and documentation requirements, creating a significant regulatory and safety risk. Professional reasoning. Professionals in hazardous materials transportation must adopt a risk-averse decision-making process. This involves a thorough review of all documentation, shipping papers, manifests, emergency response information, before accepting a load. If any discrepancies or ambiguities are identified, or if the driver has reasonable doubt about the safety of the shipment or the accuracy of the documentation, the driver must refuse the shipment and notify the appropriate parties, carrier, shipper. This process prioritizes safety and regulatory compliance above all else, ensuring that hazardous materials are transported only when all requirements are met and the risks are adequately mitigated.